Hey everyone, let's solve the problem 19th. Remove the nth node from the end of the list. Okay, so what I have been given, so let me explain the question. Suppose I have a node, suppose I have a node 1, node 2, node 3, node 4, and node 5. Okay, and they are linked together. Okay, now I told you, suppose I have n equals to 2, means remove the second last node. Okay, second last node. Okay, so basically it would be this node. So I have to remove this node in the least time taking. Okay, so what I can think of is I can make for the brute force. What you can think for the simplest kind is you can just make those arrays. Okay, and find the length of the length of the array. Suppose the length of the array is 5. Okay. Now, what you're gonna do is just go for the -2. It would be 3. So I have to take all these 3 and then from 3 I have to choose the next to next node. Means I have to choose 1, 2, 3, and 4. If I know the length of this whole node, then I can simply, instead of using array, I can just iterate one time and find the number of lengths. Then it would be better for me to calculate when I have to use the node. Suppose I know that is the length of 5. So what can I do is I keep on bouncing from 1 to 2 to 3. The moment I reach 3, I just move this link, from here to right here. And this would be my answer. Okay. But suppose I don't want to calculate the length. How can I find that? Okay. This is the also n time and space would be 1. Okay. But the thing is here the time complexity would be n plus n. Okay. Which will eventually be n, but in this we are taking 2 iterations. Okay. Now how can we use with 1 iteration? Okay. Let me clean this up a little bit for the better understanding. Okay. Now I don't want to find the length. I don't need 2 iteration. I just only want to in a 1 iteration. So what I can do is I can go for a concept called fast and slow. Okay. In this, what I'm going to take is fast is my first pointer and second is my second pointer, in which the slow will always be behind the fast. Okay. Understood? Now, suppose for F, I'm denoting with green and S would be my little, okay, purple. Okay, now, what I can do is, I'll move the fast pointer 2 times. Okay, so it would go from this to this and then this to this. Okay, now, my fast pointer is at this next 2 nodes. Okay, now, what I have to do is, let me clean. Suppose my fast pointer is at this position and slow is at this position. Now, what I'm gonna do is keep move both together. Okay, what it will? I'll move this here and this on this side, and the moment this and this side. The moment I found that the fast dot next is null, okay, is null, then I will remove this while loop. Okay. The moment I found that my fast dot next is null, and what I'm going to do is put the slow dot next equals to next dot next. Okay, I'm just removing this link and moving this link. This is the main concept behind this, and in this format, time complexity would be n, because and no, not n. N is this. It would be I'm taking n node, then I'm going for n minus n. Okay, it will eventually be a length of this. It will eventually be a total number of n iteration, which is 1 iteration. So let's code this up. Okay. So I I don't want to calculate the length of the uh, linked list. Okay. Then it will be released and the time complexity will be high. So what I'm going to do is take a fast and slow in the head push. Okay. I'm using a head fast on a head and a slow on the head. Okay. Now for I in range n. Okay, the n. Move the fast. Okay. Now the thing is, I have to use while loop for this. It could be possible that my fast could go to a null position. Okay, my fast and n. Now the thing is suppose my in I have given a linked list of three nodes and I told you to remove the first node. Okay, suppose no. Suppose I have given only one length string, one length head, uh, and I told you to remove the last node. So the fast would be this at this position. Then I can't use the slow method in this. I have to use just return the next one. Okay. If fast dot next equals to none, then return fast. Return it will be head dot. Okay. Okay. And the thing is, I shall use only fast. Let's see. I will do only fast. Then I will do it while fast dot next equal not equal to none. Okay. Then what I have to do is move both the pointers and slow. Okay. And then what I have to do is just connect the slow to the next to next. Okay. Slow dot next equals to slow dot next dot next. And then return head. And when oh sorry, accepted and this will also be accepted. Yeah. This is the main concept of slow and fast pointers. And the time complexity would only be n and space is will be one. Okay. Uh, in most of these, try not to use find the length of um, the list, and you can use a slow and fast pointer in many of the cases. Okay. Hope you understand this.